Hi everyone. In this video we're going to look at a couple of examples of reading waveform characteristics from an oscilloscope screen. So what you see in front of you is a oscilloscope screen capture, and I'm going to highlight some key things on the screen here. So this setting here, this channel 1 0.5 volts, that really means volts per division, right? And this 2 milliseconds, that really means 2 milliseconds per division. Okay, so the volts per division is talking about our vertical scale, and that's giving you the distance that, or the voltage that each one of these squares covers. So each one of these vertical squares, these major divisions, is 0.5 volts, and horizontally each one of these big squares is equal to 2 milliseconds with the settings we have shown here. So knowing that, I can start to read some data from the screen. So if I want to read V peak to peak, now it doesn't say explicitly here, but I'm going to assume that that's the 0 volt level. It's not always, but let's make that assumption for now, since we don't have a real scope to check the settings here. And I want to know what V peak is, so that's the distance from here to there is V peak. And I can figure out what that voltage is by counting that there is 1, 2, 3 divisions. So V peak is going to be 3 divisions times 0.5 volts per division, and that is equal to 1.5 volts. Okay, now V peak to peak, I could either double that number knowing that it's double, but to measure from the scope, if I want V peak to peak, what I'm going to do is measure from here to here. So that is 1, 2, 3, 4, 5, 6. So I'm going to say V peak to peak is 6 divisions times 0.5 volts per division. The units of division cancel out, and I'm left with 6 times 0.5 volts, which is 3 volts. Okay, so my peak to peak voltage is 3 volts. Now, if I want to measure the period of this waveform, I know that the waveform starts here and it ends here, so I can see that one period takes oh dear, let's count that over again. Okay, so 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So it takes 10 divisions, which I knew knowing that this screen is 10 division wide, but some modern scopes actually have more than 10 divisions, so not a bad idea to count. So 10 divisions, the period is going to be 10 divisions times 2 milliseconds per division. The period is therefore 20 milliseconds. And if we want to find the frequency from that, we know that frequency is 1 over the period. So frequency is 1 over the period is 1 over 20 milliseconds equals 50 hertz. And don't forget to include the unit milli, so times 10 to the minus 3, when you're inverting that number, when you're taking 1 over that number. Okay. Let's bring up another scope screen, and we'll do this same exercise again. Okay, so for this scope screen, we can now see that we have a little bit more than one cycle of the waveform on the screen, and we can see that our settings have changed. Channel 1 is now 50 millivolts per division, and the seconds per division setting is now 0.1 milliseconds per division. So let's write that on the screen so that we remind ourselves that This is per division, right? These settings are per division. So now when I want to read V peak, now I'm going to count this. I can see that I don't go a full division there. It's a partial division. And if I line these up, I can see that it's hitting this point here, which is 0.6 of a division, because each of these ticks here are 0.2 of a division. There's five spaces there. So what I have here is a distance of 1, 2.6. So that's 2.6 divisions. So V peak is going to equal that 2.6 divisions times 50 millivolts per division. That is going to be 130 millivolts. And if I want V peak to peak, again, I could just double that, but often in the lab I'm measuring V peak to peak. I'm not measuring V peaks, so I would count from here to here. Now on a real scope in the lab, I would actually lower that waveform down until this bottom point was sitting on a major division. That way I only have to read partial divisions once instead of twice. But in this case, obviously I can't move the waveform. So I've got 0.6 of a division here, then I've got 1, 2, 3, 4 full divisions and another 0.6 of a division. Oops, that's not, yeah, division there. So this total is 5.2 divisions, right? That total is 5.2 divisions. So if I want to know what V peak to peak is, trying to change my pen color here with not much luck, but okay, so V peak to peak is going to be this 5.2 divisions times 50 millivolts per division, which is equal to 260 millivolts. Okay, the period of this waveform, I can see that one period goes from here to here. If I count that, I've got 1, 2, 3, 4, 5, 6 divisions. That makes it easy for us because it's even divisions. I've got 6 divisions times 0.1 milliseconds per division. That is 0.6 milliseconds. And the frequency is going to be 1 over the period is 1 over 0.6 milliseconds equals 1.667 hertz. Okay, so there you can see in this video that, you know, if the waveform characteristic that you're measuring doesn't fit within, you know, perfect even major divisions, you have to take a look at those tick marks, which are 0.2 of a division, and see, you know, how many of those you have to include when you're counting divisions. Okay, and when you make the waveform as big as possible on the scope screen, you can make that reading in the most accurate way. Okay, so this assignment for reading the scope is posted on Blackboard. There's 2 more little screens like this where you can practice your reading. The answers are given if you want to check, but you should definitely try it yourself without peeking at the answers to see if you can work out how to do that. Okay.